So our last speaker is Angela Zhou. Angela will talk about her work on fairness, welfare, and equity in personalized pricing. Angela is a fifth-year PhD student at Cornell University, Cornell Tech, in operations research and information engineering. She works at the intersection of statistical machine learning and operations research, and her goal is to inform reliable data-driven decision-making in view of fundamental practical challenges that arise from realistic information environments. In particular, her research has focused on robust causal inference for decision-making and credible performance evaluation for algorithmic fairness and disparity assessment. Okay.
Great, thanks. Thanks for the introduction, and thanks for the opportunity to speak. Can you see my slides okay? Okay, great. So I'll talk today about this project on personalized pricing and looking at the interaction between fairness, welfare, and equity. And at the end, I hope to zoom out and put this in context in a broader empirical toolkit for going from methods to assessing empirical reality to improving empirical reality. So first, I want to put, so the first half of this paper is really more of an inductive literature review, which is trying to draw upon the ways in which pricing has been used in practice, in particular algorithmic price optimization, and understand where considerations about fairness or disparities may come up in relation to algorithmic pricing, because that's just such a broad methodology. And so kind of like activating distributional considerations, a kind of first important distinction is that this paper is not really going to talk about discrimination, which is on the one hand, a kind of extremely powerful and well-established normative framework to think about price differentials, which is particularly important in insurance and lending. This paper is going to focus more on emerging considerations that can be relevant when it comes to value-based pricing. So trying to estimate an individual's valuation of a good and using that kind of predictive information to make separate kinds of price offers. And so the reason for this is because actually the regulatory discussion about algorithmic pricing is generally more optimistic about the potential benefits of algorithmic price optimization and value-based pricing, whereas price optimization is kind of generically expected to overall harm members of protected attribute designations due to either differentially equipped negotiating customers or the bias of pricing agents themselves. In contrast, when it comes to value-based pricing, the kind of underlying patterns of inequity in the world could actually lead to potential benefits in terms of increasing take-up, because low-income individuals may be more price sensitive and price optimization can increase access. And so that's an important first distinction that motivates looking at the setting of value-based pricing and revenue management. So this paper is going to focus on value-based pricing and specifically look at considerations regarding measurement and what can be said about these kinds of fairness or welfare considerations under realistic data sets. So in contrast to conventional economic analysis, I'm not going to assume access to valuation distributions. And the second half of this paper is looking at possible trade-offs between different kinds of fairness considerations that could be relevant. And so as mentioned, the kind of main objection to conventional welfare analysis of price discrimination is that social welfare is defined classically as consumer valuation minus price. Now, in realistic settings, how is it that we estimate a consumer's valuation? It's by revealed preference based on purchasing behavior. And so we should first understand that this willingness to pay that is estimated from purchases from unequal incomes better reflects an individual's ability to pay rather than some kind of true willingness to pay or valuation elicitation. And so that's going to motivate defining various fairness notions relative to what can be learned from realistic data or binary feedback data. And so what is the personalized pricing problem? So I'm going to consider pricing that is personalized based on X-based covariates or a protected attribute upon which I would like to estimate disparities or so on. And so this is the predictive information that would be used to estimate personalized demand at a price given covariates. So in targeted advertising, people purchase all kinds of marketing segmentation data to estimate your probability of purchase at various kinds of price offers. And kind of importing what we might expect from the fairness machine learning literature, once we have this kind of conditional expectation or predictive model, there could be interactions between protected attribute information, proxies, and other kinds of covariates. So the decision variable here is going to be a per individual personalized price, P. So it can vary in both X and A, and it can also be within some kind of restricted function class. So of course, when it comes to value-based pricing, thinking about the firm-centric point of view, the firm is maximizing revenue, which is price times the realized demand, or the demand random variable, and a personalized pricing function in terms of just revenue management is going to optimize the expected revenue conditional on this information. So one can simply, now that we've considered the personalized pricing problem, there's really only a few different objects. There's prices and there's the realized demands that we can truly measure from data. And so we can simply think about trying to map disparities or parities in these quantities across groups to specific concerns that come up in actual application areas. So the paper tries to include a lot of examples to justify these, but on the one hand, we can think about, or people can be concerned about price differentials across groups in the distribution or marginally or various moments. And one reason for doing that is because pricing has an impact on people's budgets, and there's this kind of indirect mapping to utility via money. But secondly, prices are actually their instruments themselves, or they induce particular allocations of the good or resource in settings where perhaps resources are not explicitly assigned. So there's an implicit resource allocation under a kind of price rule. And one could be concerned about equitable access to beneficial resources, regardless of income differentials. And that could be reflected by having distributional preferences on the demand realizations themselves. A third consideration, and this relates more possibly to what Anna was talking about at the end with mechanism design, is that classically, prices are really important and they have a lot of normative associations because prices allocate goods to those with higher valuations. But this kind of interpretation of a price relies on, for example, ideas of competitive equilibrium from equal incomes. So this is the kind of allocative efficiency interpretation of prices that comes up in settings where valuations are kind of viewed as valuations themselves. And the kind of last consideration is more kind of like inductively derived from the literature. And it's trying to rationalize why people might care about equal access or increasing access. And it's the idea that prices allocate goods that themselves have effects on individuals. So the actual object that is being allocated has some kind of treatment effect on an individual. So loans in household finance, vaccines in healthcare, or bed nets in development economics. And so in these empirical examples, there's some citations in the paper to mid-thousands development economics that looks at this. Essentially, one expects that there could be systematic differences in revealed preference based on income. But in this setting, it could be that underlying patterns of inequity kind of work well together with personalized pricing, because personalized pricing could increase access. And for these individuals that it prices into the market, there specifically are increased possible heterogeneous treatment effects that lead to greater welfare impacts. And so that one's a little more speculative, but it does appear in some of the exposition or discussion about some of these original papers. So having identified these various notions, we can of course define operationalizations of these by just differences in these different objects. We can kind of think about essentially taking the conventional revenue management problem and adding fairness considerations in this sense. But a kind of important point is that, of course, we don't care about all of these aspects at the same time. So the second part of the paper is really just looking at trade-offs or implications for algorithm design, but more so two at a time. So thinking about what happens if we might be concerned about adding a little price parity. So as an example of a kind of implication for algorithm design, I'll talk about the setting where we might want to add a constraint that the prices are equal on average across groups, having this be an average, and one can also have this be less than some kind of caliper value. And the kind of substantive question is, what are the trade-offs between attribute-based prices versus attribute-blind pricing schemes? And so we can say something about this if I impose parametric demand assumptions, such as linear demand models, which are actually quite common in practice. And so one can compute the constrained optimal prices. And what happens is that if we allow the fair price to depend on both context and the group, then the adjustment from the unconstrained optimal price is actually a group-based lump sum penalty that only varies in the group attribute. And so although, because we're optimizing overall the information, this has the optimal revenue property, may be undesirable for a number of reasons. We're using the group-based penalty itself. Of course, if we remove the protected attribute information from the decision variable, then we have a penalty that differs only in the covariates. But of course, the firm is going to have lower revenue. But if we impose some additional structural restrictions, so price differentials are due only to differences in covariates between groups, not actual price elasticities, then we can see that essentially there's this kind of proxy type issue with an attribute blind price in the sense that for members of groups who are outliers in the sense of the likelihood ratio of them being a member of the group based on their covariates, of course, not using this group-based information is going to lead to a higher price offer for these individuals. And so actually attribute-based pricing would be preferred for members of both groups, just based on the magnitude of the price, because trying to restrict the protected attribute information from the decision variable is going to introduce some suboptimality. So this is essentially a trade-off between implementability and other kinds of desirable properties of the allocation itself. So I won't talk about some of the other analysis in the paper. We also take a look at data to look at some of the distributional implications of a kind of simple covariate-based personalized price mechanism. So the first example is a valuation survey for an elective vaccine. The group membership information is low or high income. On the left is a simple group-based segmentation. So we can offer a lower price to members of the lower income group that induces some loss in revenue relative to a uniform monopoly price, but of course increases market share for the minority group because we can lower the price offer to them. On the right is a kind of purely covariate-based personalized pricing metric, so much more variability in the price. And so we can achieve more revenue from the uniform monopoly price, and we can actually increase the market share relative to the simple group-based subsidy. So I won't go into too much detail about the data examples, and I'll just conclude with a kind of summary slide, trying to put this in context in terms of this empirical toolkit from methods to empirical reality to improving on empirical reality. So this paper about personalized pricing, to put this in context, I think is trying to think about how can we move away from binary decisions and think about other kinds of decision levers that are available to us to kind of improve outcomes. And how is it that we improve outcomes? Well, this is dependent on having estimates of welfare, which can be difficult to accomplish empirically. So I'll stop there and thank you.